Welcome to the video on Lewis acids and bases. Let's just recap what we know about acids and bases so far. There's actually a total of 3 definitions for acids and bases. In your pre-AP year, you learned the first 2, and they're the most important ones. Arrhenius was the first guy. He said that acids yield hydrogen ions when you dissolve them in water, and bases yield hydroxide ions when you dissolve them in water. Then along come Bronsted and Lowry, and they said, well, that is a lot of acids and bases, but there are some more chemicals we found that are acids and bases that don't fit this category. So they made a new, more inclusive definition, and they say that acids are the ones that lose the hydrogen and base gains the hydrogen in a reaction. They exchange a hydrogen. And this definition is pretty good, and this definition is 90% of what we use when we do chemistry. But there's one more definition that is used a couple of times, so I just wanted to make sure you know it. This is the Lewis acid and base definition. According to Lewis, these guys both dealt with hydrogen ions primarily, which are protons. He looked at it the opposite way. Again, he found chemicals that acted as acids or bases but did not fit these definitions, so he needed a more inclusive definition. And he kind of flipped everything on its head and said, let's look at the electrons. What's happening to the electrons? Here it says I'm losing a proton and gaining a proton, but you can actually look at it in terms of electrons. It's actually the reverse. An acid is something that gains a pair of electrons during a reaction, and a base is something that loses or donates. Let's say donates. Donates a pair of electrons. So let me show you an example. Let's say we have ammonia and boron trifluoride. Ammonia has an extra pair of electrons right there, lone pair, and boron trifluoride is actually an exception to the octet. It does not have enough electrons. Boron doesn't have a full octet. So when these two react, nitrogen can donate its pair of electrons to make a coordinate covalent bond between the two of those, and that bond came solely from the nitrogen. So therefore, in this case, according to Lewis's definition, the ammonia is a base. And we're like, well, we already knew that, ammonia is a base. But we didn't know anything about boron trifluoride. There is no hydrogens being exchanged here, so we would not have thought of that as an acid or a base. But in fact, it is. If this is a base, this is the acid, it's the one receiving those electrons. So that's the basic idea of what's a Lewis acid and base. How are you going to see this? First of all, most of the time we talk about Lewis acids, you may see this particular reaction sometimes on the test, but most of the time when they're talking about Lewis acids and bases, they're really just talking about Lewis acids. And these are often cations. Cations are missing electrons, just like boron was missing an electron. So somebody else, for example, cyanide, could come along and donate a pair of electrons to that. And so then this would be acting as the acid, because it's receiving electrons, this would be acting as the base, because it's donating electrons. So we often talk about cations as being Lewis acids, and as far as acid strength, the larger the charge, for example, 2 charge versus 3 charge, the larger the charge and the smaller the atomic radius, aluminum is smaller than iron, the stronger it is. So, stronger. Okay. So that means that if you're an acid, you're attracting a pair of electrons. So the smaller you are and the more positive you are, the more strongly you're going to attract that pair of electrons. And so that's basically all you need to know about Lewis acids and bases, just mostly identifying who's an acid and who's a base. Thank you.